Next curve.
Hey everyone, this is Leonard Lee, Executive Analyst at Next Curve, and welcome to this episode of the Rethink Podcast. And I'm here in Taipei City for Computex 2024, and I have the distinct, special, exuberant, wonderful opportunity here today and honor to have Jim McGregor of Tirias Research joining me here to recap Computex 2024, which was actually quite ridiculous, right? Was it?
Oh, yes.
Yeah, I mean, it's not entirely a huge event.
No, but it's really has kind of been shrinking over the years. But everything this year was AI PC.
Can you please not say AI PC?
Okay, Copilot plus PC.
Well, you know, we've been warned. We've been warned. Okay, or at least it's our observation that we should not start off with AI PC. And we know that all of you are just absolutely dying to hear about AI PC. So we're going to leave that for the end. So before we start, remember to click like and all that nice social media stuff. Share. You must share because we have Jim on. And if you don't know who Jim is, that's absolutely wrong. Jim is the man, I am telling you. And you have to follow Tirias Research and Jim, as well as Francis and
Kevin.
Kevin, yeah. I mean, these guys are legends in the industry, analyst industry, right? Does that make sense? Industry, analyst, industry.
I guess so.
Research, okay. But anyways, we're gonna hold AI PC for last.
Okay.
But Jim, what impressions, just overall, the event, the vibe, what'd you get out of it?
A lot of excitement. And obviously AI is the undertow here.
Yeah.
But we saw it not just in the PCs, but we saw it obviously in the data center too.
Yeah.
And we got an update on some of the key data center roadmaps that are coming out. Obviously, with the growth of AI and Gen AI, there's huge investments in the data center.
Yeah.
And we saw, a strong commitment by all the major players, especially AMD and NVIDIA, to really up their game, to, really deliver significant improvements in their solutions and new architectures every year.
Yeah, they call it the 1 year cadence or something like that. Yeah. And I mean, it's pretty aggressive. I mean, I was going to say extraordinary, but I do have some reservations about it because that velocity of improvement, it could be difficult for a lot of organizations to digest, even the hyperscalers who are, the primary buyers. That's just my take.
No, you're right. You're right. Because, I mean, every generation, they're increasing the power consumption.
Yeah.
And a lot of the data centers can't handle that. So it's going to be a challenge. Intel, on the other hand, is also updating their roadmap for data center. And they're trying to bring the power consumption down through their new efficiency cores.
Yeah.
So it'll be interesting. It's going to be a challenge.
Yeah, Xeon 6, by the way. So that they announced it actually even before Computex, and we'll have a separate session on this. We attended Intel's technology tour, which took place here in Taipei City the week before Computex. So we got like a whole major download on all the big Intel stuff, right?
Yeah, especially on their Lunar Lake processor, on their Xeon 6, on Gaudi 3.
Yeah.
So the major stuff for the client PC and for the data center.
Yeah. So there was one thing. So I don't have my notes in front of me, but I want to riff off of you, or at least ask you the question. One of the things I thought was really unusual was this year, I think with Xeon 6, they mentioned that they're not going to be hyperthreading. Right?
That is with the
or is it Lunar Lake?
That is actually on the Lunar Lake, and that is with the P cores that they're doing, and the fact that they switching from Meteor Lake to Lunar Lake, they basically took hyperthreading out of the P cores.
Yeah, that's what I thought.
And it makes sense when you think about the fact that now they, hyperthreading made a lot of sense when you just had one core.
Yeah.
Because you want to multiply that core as much as you can.
Yeah.
Essentially, they're taking care of hyperthreading with the E core now. So that now they've got a low power core just for that, and they've got the P core for the performance, and they keep as much on the E cores as possible.
Yeah.
And they did a great job. Lunar Lake is a completely redesigned processor over Meteor Lake.
Very different.
Also, you know, there was a lot of overhead associated with doing hyperthreading in terms of extra die area, in terms of extra security and partitioning and everything else. So there's trade-offs. There's trade-offs. And they basically came down to it's more performance per watt per area if they went this route with the E core rather than doing hyperthreading.
Well, you know, so here's an interesting thing that I've been talking to a lot of the semiconductor companies about is, you know, confidential computing, right? And, you know, of course, we all know why that came about, right? And so that announcement that they were going to take out hyperthreading, or they're going to deprecate it from Lunar Lake, I thought that was an interesting move. In that it kind of mitigates some of that the let's call it attributing challenges when we look at deploying models, AI at the edge, and this whole increasing, I think, priority of being able to secure models, making sure that there's trusted environments that you can truly have on endpoint devices, because right now confidential computing, most people think of it in terms of like the server and in the cloud, right? What I'm going to be really interested in hearing from the next team in particular, because they're looking at using a lot of they're already doing it with Meteor Lake, right? Or what's better known as Core Ultra. Taking that out to the IoT edge, right? And I think that's where you're going to see a treatment or a prioritization of, let's call it, confidential computing for the edge really start to take shape. Right. And so that I thought that was interesting. That was, and I'm going to be interested in seeing how Intel parlays that as they take
and
that processor out to
not
the edge
just Intel, because we also saw updates from AMD on what they're doing at the edge, primarily through their Versal series. And a lot of that has a lot of those components in it as well. And so I mean, that was kind of an underlying toe, I think, is the fact that, you know, everything we're doing in client, everything we're doing in data center, we're also feeding into everything else. So it's gonna be in that embedded IoT world. So now, good observation, by the way. That was great.
Yeah, I know. I pick up on weird things, man. But it's always good to have the real expert here sitting right next to me to vet my wacky thoughts. Oh my God. I think he's up there sitting playing guitar, actually. But yeah, I mean, I thought. So let's talk about the different companies that we spoke to. Obviously, I mean, the event started off with a rather unconventional keynote session by NVIDIA. Right? And we both attended.
Well, actually, that was the thing, is there were so many keynotes this year. NVIDIA, AMD, Intel, Qualcomm, NXP, Supermicro, MediaTek,
Delta.
It was ridiculous.
It was kind of crazy.
You could spend the whole conference just going to keynotes.
That's basically what the first 2 days were. But yeah, I thought. I mean, you tell me. What did you think about the NVIDIA keynote? I know that there were a lot of people opining about it, but
it was not a lot of new stuff. I mean, it was repackaging what we've seen before and kind of enhancing what we've seen before. The one key thing there was obviously for the data center, giving us a roadmap for what the data center GPU series looks like for the next 2 to 3 years. 3 years, I guess now. So other than that, and kind of explaining it a little bit more. Why are we going down this path? Why it matters, and really, the whole point is that we need to not just increase computing performance by 2x. We need to increase it by 1,000x. Every couple of years. And that's a real challenge.
Yeah, exactly. And of course, they talked about what's coming beyond or after Blackwell, right?
Yes.
He teased Rubin, which everyone got really excited about. So that was probably the biggest net new, right? Or at least for
NVIDIA, yes.
And then this notion of 1 million GPU. I mean, with Rubin and beyond, this whole idea of 1 million GPU data center.
Oh, yes.
Yeah. I don't know, Jim, what you think, but I know that everyone is going crazy about GPUs and the prospects of selling through whatever this massive TAM is that everyone talks about. But I think, honestly, even as we're watching the NVIDIA keynote, the question is still for what, right? Is it really going to be for all this training of, large language and large vision models and mixture of experts? I mean, is this really where these investments in GPUs are going to find a return,
Well, first off, obviously the power needs to come down because we can't power everything over the next decade if we keep going up this route. So they need to bring that whole cost equation down, and that's a key thing. Keep increasing the performance, bring the power down, make the justification. And we're starting to see the rubber hit the road, where we're transitioning mostly from training towards inference, where we're actually using these models. And Blackwell's a good example where it isn't really targeted towards that really high-end training, the FP64, but it's more it's FP32 and on down. And it makes a very good solution for inference processing. One thing that really amazes me, everyone says, well, maybe we should just go to ASICs for inference processing and everything else. The problem with that is that AI is still changing. Now we have RAG, so now we're introducing retrieval augmented generation with these pre-trained LLMs. And we're going to go, like you said, to vision processing, where that's going to really blow things up. It's changing so drastically that the one good thing about the GPU is it's programmable. It can change with it. And as we've seen with the GPU, we can keep scaling it up to support, large data centers just for inference or for training or for both. So I think it's still, a challenge to get that ROI down. But the way AI is changing and so fast changing, I would venture to say we're going to see some of that return in the next couple of years.
Okay. All right. I guess we'll see. But let's talk. I mean, you mentioned RAG, and we're gonna skip over. Well, actually, we'll skip over Qualcomm for just a moment, and we'll treat them in the last thing that we'll talk about, right?
Okay, that thing that shall not be spoken
until the very friggin' end. But one of the things that I got out of Pat Gelsinger and the Intel keynote was, and also, at ITT, a comment that MJ made, or Michelle Halthouse Johnson. For those of you who don't know, she heads up CCG, which is the client computing group. When it came to, let's say, the broader applications for AI, right, generative AI, where in most instances you're going to be using a RAG. I mean, fine tuning. Number one, costly. Number two, you got to do it all the time, especially if you're using it for anything that needs to be current.
And personalized. And really, that's a huge value. Personalized.
I'm glad you brought that up. I mean, exactly, because the LLM needs to go off of a corpus of information, whether it's through some aggregation of stuff from retrievers into a graph or a Microsoft talks about graph vector quite a bit. Yeah, that's the only way that you can get these things current. And then, like what you said, personalized. Ideally,
that's
kind
the
of
pot of gold
you,
for
right?
early AI is that personalization.
Yeah, but it's interesting to see the divergent philosophies where on one end you kind of have, I think, let's call it the GPU camp thing, asserting, well, everything is done, all these different workloads that are associated with a generative AI application is going to be just, GPU stuff, right?
Yeah.
But then when you talk to the Intel guys, they take a different slant. It's more of an XPU type of thing. It's like, look, there's certain workloads when you look at an application stack and all the different kind of inferences that happen, non-AI related operations that happen. When you look at these applications, GPU is going to have a role, MPU, and the CPU will definitely have.
Yeah, as they put it, the CPU is really those bursty type applications. The NPUs for those always on, very low power type applications, like always monitoring your camera and speech detection, stuff like that. And then the GPU, it's really that heavy lifter. It's going to have that extra burst of performance for that LLM and stuff like that. And I would tend to agree with that because no single AI workload is singular. It's always multiple workloads. So you have to be able to parse that up accordingly and to be able to do it efficiently. So we're going to have a lot of those applications, some of the Copilot applications that are going to be small workloads, and they're going to be really optimized and really fit well on the NPU. But you have to remember that a lot of those larger workloads, well, a vast majority of AI workloads still run on a CPU. And a lot of those heavy workloads, are born from the GPU. Both from training and inference processing and everything else. And, there's also a learning curve. You got to remember that a lot of the programmers out there know how to program to a GPU. They don't know how to program to an NPU yet. And we have multiple different types of NPUs. So even with direct ML from Microsoft, it's still going to be a bit of a challenge as we kind of evolve the industry to be able to really utilize the NPU or multiple NPUs. We even have different NPU architectures. You have to remember that Qualcomm and Intel are basing theirs on DSPs, AMD's is based on FPGAs. So it's not apples to apples in any means.
So let's give AMD a little bit of love before we get on to the topic that should not be discussed until the very end. So let's talk about AMD data center. Obviously some enhancements to MI300, right?
The 325X.
And we got the 325X, right? So any color that in perspective you want to share with the audience?
Well, AMD mentioned that the MI300 is the fastest ramp they've ever had with any product. And rightfully so. NVIDIA has been sold out through at least the middle of next year. Now people are looking for a second source. AMD is the most viable second source out there. They're proving to be very well suited with the 300. We didn't see some of the problems and issues we have with the firmware with the 250X. So it's proving to be a very good solution and an alternative solution, especially for certain types of workloads that it's optimized around and that ROCm works really well with. So, it's kind of natural, and they're seeing, and especially the hyperscalers. It's to the benefit of the hyperscalers to have instances for every different types of architecture because, one workload may work well on this architecture, one may work well on this architecture. So it makes a lot of sense. And I think even though we've seen the hyperscalers and the big guys really take most of these GPUs from NVIDIA and AMD, I think we're starting to see more demand and more interest from the enterprise, as long as it fits in their data center, which is a challenge.
And the other thing, so I ended up getting quoted in Bloomberg for this statement that, one of the more important things, I think conventionally people are thinking that, okay, the GPU is, or whatever, the accelerator is really the thing that's driving the scaling and the densification of these systems. But then it really does now boil down to the interconnect.
Yes.
And the networking, right? I mean, it almost has like the outside, because so if you see these generation over generation improvements, there are two things. Number one, that interconnect and networking, and the other is data, the data type and the precision, right?
Yeah.
And the compression technology. It seemed to really have that huge factor. So when you see Jensen show that curve, I mean, that hockey stick part is really going from FP8 to FP4 over, H100 to Blackwell. And so that's why you really see this, seemingly...
Yeah, it does kind of accelerate the curve when you're starting to do quantization down to lower precision levels.
Right.
But you brought up the great point, and that in fact is that it's not just about the GPU architecture. I mean, Blackwell, obviously, it creates another jump in performance. However, the real shining star of Blackwell is really the NVLink chip. Going to a multi-link chip to where you can basically make every system in a rack or every GPU in a rack look like a single GPU.
Right, exactly.
That is huge. That is huge.
Yeah.
And now, and NVLink is such a higher performance solution than PCI Express. That now everyone else is banded around
UA
Link, which is based on Infinity Fabric, or at least the first version of it off Infinity Fabric from AMD.
Yeah, big deal, because you have Broadcom, you have Meta, you have
Google, Intel, AMD,
Microsoft, all these guys. Yeah. And so I think it's going to be one of those important.
UA Link, by the way, stands for Universal Accelerator Link.
Yeah. And then there's also Ultra Ethernet, right?
Yes.
Yeah. And so these two things are really.
That's usually rack to rack.
Yeah.
Right. Or InfiniBand. It's an alternative to InfiniBand.
Don't tell me. Tell them.
It's okay. Yes.
He's an amateur. He doesn't do this very often. So hey, have a drink. Cheers.
Cheers.
So, I mean, that was a big deal. I don't know if the general audience really picked up on that, but definitely gearheads like you picked up on it big time, right? And I think you hear, but obviously NVIDIA has Spectrum X, right? Their Ethernet offering. So this is the way they kind of play nice with the other non-NVLink InfiniBand environments. And so
well, you have to remember the data center is going to be a multi-architecture data center. So you're going to have the standard CPUs, you're going to have the accelerated servers, and and even NVIDIA will admit this, eventually you're going to have the QPU. So you're going to have quantum processing units.
All right. We're going to have to ban you. You use the Q word. Jim, what did I tell you about the Q word? Dang it. So, okay. So I think we've beat that data center horse to death. So let's move on to ultimately what is the last topic, which is actually it was the topic that dominated the event.
It was really the whole reason this event really took what it did this year. You have to say it. I'm not going to.
AI PC.
Yes.
And
I thought we weren't supposed to say 4-letter words on these things.
I know.
Okay.
I know. I think we might just squeak by. But I mean, what did you think?
It's impressive. Obviously, we're reaching a point. Microsoft looked up last year and said, we define an AI PC as having this to support Copilot. And a key thing there was 40 TOPS of NPU performance. minimum amount of memory, 16 gigs.
Yeah.
As well as the SSD, 256 gig SSD and stuff like that.
Yeah.
Now we're seeing, especially on the silicon side, the SoC side, Qualcomm's the first out of the gate with the Snapdragon X Elite. Intel has formally introduced at the show, Lunar Lake, which is going to meet those with 48 tops of performance and 128 tops of platform AI performance. And we got Strix from AMD that's going to come out of the gate with 50 tops of AI performance. We don't have all the details about Strix yet, even the platform level.
No, 50, 50
tops of NPU performance.
Yeah, they're kind of avoiding the whole platform tops thing.
Yeah. But we've got, in June, we'll have the AMD or the Qualcomm products.
Yeah, 18.
And then in July, we'll have AMD. And then later we'll have Intel.
Yeah, Q3.
Yes.
So all this, I mean, it's tightening up. We have a lot of
Actually, maybe Q2. No, Q3. Q3. Sorry.
This is Q2.
I know.
It's almost over.
It's been a long day.
Yeah. No. So yes, full disclosure, we are absolutely exhausted. Yes. This is day 3, and it's been nonstop. We didn't even get to have lunch.
Day 3. What are you counting? We've been here for over a week.
Yeah. But those of you who think that this is all fun and games, we actually starve in the middle of the day.
Yes.
To absorb all this information and so that we can synthesize it and bring it to you. Okay, so this is probably the most disruptive environment or unstable or weird environment that I've seen in a long time. That it's just, you just feel it. And I think, definitely Qualcomm has come to the table. They're poised to prove, and it's very likely that Windows on ARM is going to be a factor, right?
It will be a factor not only for what we consider the PC, but also in the competition with Apple.
Yeah, you always say that. I don't know. So I kind of differ in my opinion there.
Well, you're a fanboy.
But that is, that has nothing to do with that. Come on, man. No. I think what Qualcomm has to prove is that it can prove itself in the PC space first.
Absolutely.
Now, Microsoft is a different story.
Yes.
Right?
Well, and Microsoft's story is that we can compete with Apple.
Right. Which is weird given how much the PC x86 world pans the Apple stuff. But, but that's, I guess, the reality that the ecosystem has had to deal with. But, definitely the X series, Snapdragon X series, is very... X Elite, but remember there's two. Plus. Yeah, right. So, Qualcomm likes for us to call it the X series because it's kind of a family, family of processors. But
isn't that a TV show?
I can't work with this guy. It's ridiculous. Yeah. But
X-Files.
And I think here's one of the things, man. Though I think the AI PC really diluted what the Orion CPU, which was, it's basically the new the CPU cores IP that they got through the the acquisition of NVIDIA. How important that is, right? Because there's so much attention on the MPU.
Yeah. It is important, and it's important to note that the two competitive ARM compatible, and I say compatible because they're not really ARM standard cores. So when you look at what Apple's doing, you look at what Qualcomm's doing, both of them have their own custom CPU design architecture. They just use the ARM instruction set.
Yeah.
So that was completely designed from the ground up from a group that originally was focused on servers at NVIDIA. to come out with a very power efficient core for PCs and smartphones and other mobile devices. Other
automotive, eventually.
Yes.
Coming soon.
Yes.
Right. At a Snapdragon Summit near you.
But you're right. That was a focus on creating a CPU core that was very competitive in terms of performance. And it was kind of diluted when you think about that the messaging was all about the NPU.
Yeah. But I think the mainstay of Qualcomm's inroads into the PC game, I think, is really rooted in that. At least that's my take. You can beg to differ.
No, I would agree. They were kind of trailing behind performance, and Orion brought them up to the table.
Yeah. And the reason why I say that, actually, you substantiate it a bit, because developers still don't understand what to do with the NPU.
Yeah.
So out of the gate, the NPU has to really define itself in a lot of ways in front of developers and ISVs. And, I think there's a lot of potential there.
Yes.
Right. And I think there is a bit of a myth that it's slow.
Well, and we think of,
power efficient, but slow.
Even what we saw from the previous generations, which most of them were like, a couple of tops to maybe 10 tops.
Yeah.
Now we're up to 40 to 50 tops.
Yeah.
That's a huge jump in terms of NPU performance.
Yeah.
I think, what we see over the next year is going to be phenomenal. Yeah. Because you give a software developer a tool and more performance, they're going to figure out a way to use it and then ask for more.
Yeah.
So the question is how are we going to be able to scale these NPUs? I mean, that required more silicon by all these SoC vendors.
Yeah.
Can we, that was a 4x jump or more by most of these guys. Can they do another 4x jump next year? Can they do a 2x jump? They're going to need to be able to keep up with that requirement.
Yeah. So when we look at the different offerings, right, from AMD, Qualcomm, Intel, it seems like they made interesting bets on design, right?
Yes.
Because we have to remember, and Intel, as well as Qualcomm and others, will remind us that these decisions were made a while back, right?
A few years ago.
Yeah, and some of this generative AI stuff just came in and changed a lot of stuff, right? Their assumptions of what compute needs would be on a PC.
And they're even using different architectures. I mean, you got to remember that AMD's is based on their FPGA technology from Xilinx, while Intel and Qualcomm are using DSP-based technology. So they're not even, the NPU architectures aren't even the same.
Yeah. And, my take was this, as we were listening to, Qualcomm, Intel, AMD kind of talk about their designs. I thought, I don't know what your impression was, but when I was looking at what Qualcomm specified for the Snapdragon X series, it was pretty CPU heavy, right? Because they have the Orion all performance core design.
And that's a huge jump.
Big jump. Then they, I think they were probably a little bit moderate with the GPU, heavy with the NPU, right?
Yes.
And then we saw what Intel did with Lunar Lake, and they took their priority was energy efficient CPU, right? Came in pretty heavy with the GPU. Pretty heavy with the
they changed everything on it.
Yeah. And I kind of characterize that as being sort of a AI compute heavy configuration. And then AMD, of course, they only specified 50 tops, but
on the NPU. It is kind of ironic. Obviously, the entire platform is going to be important. The vast majority of inference AI workloads today run on a CPU in the cloud. The GPU is primarily used for training and running those larger language models, especially for Gen AI. So it's a kind of natural place, and programmers are familiar with using the GPU. It is kind of ironic that we're seeing different messaging. Qualcomm actually traditionally has had this AI engine message where it's CPU, GPU, and the NPU. For this product, for the X Elite series, they basically, focus mostly on the NPU. Some of that obviously is a focus around Copilot and Microsoft messaging. but Intel took the whole platform. AMD really just focused on the NPU. I would expect that all of those things are going to be important, and all the vendors have it.
Yeah.
So and it's really hard to judge where each one is at this point in time.
Yeah.
They're so close.
Yeah. I mean, exactly like what you're saying. And the NPU has to prove itself. And if we were to go back to the Snapdragon X series, the Orion cores, those are based on the Nuvia acquisition, right?
Yes, completely. It's not an ARM standard core; it's completely custom core.
Yeah. That really being sort of overshadowed by NPU, but I think that, I mean, if you were to sit there and contemplate, what is that thing in these new Qualcomm chips that are foundational to its entry and viability in the PC market? It really boils down to that.
It really is Orion. It brought them to the table.
Yeah.
In terms of performance.
And I think that is that big deal. I think that's the thing where the x86 world is facing a moment of reckoning.
Yes.
And then obviously, as we see these devices come to market with, the Snapdragon based devices coming out in June 18th. I think that's the target date. AMD, I think, is what, July? Yeah.
And then Intel will be later in Q3.
Yeah, Q3. So we're gonna be able to see how these things match up and what OEMs are able to do with these different designs and technology sets, right?
So what do you think of this staggered release? Typically Microsoft has even held people back, like when they went to 64-bit, to make sure they had both AMD and Intel launching at the same time. What do you think about them doing this kind of multi-stage thing with different vendors?
What did I say before? I think I said that it was weird.
It's weird.
It's just really weird, right? It's very strange in that, there seems to be a lot of different agendas and priorities, right? And when we look at Copilot PC, obviously, it's very obvious that Microsoft is leaning in really heavily with Qualcomm and its Snapdragon X series, right? It just happens to be the first design that came in to spec for what Microsoft expects for a quote-unquote AI PC, right?
But as you mentioned earlier, it's causing fragmentation.
Yeah.
And kind of confusion.
Well, the confusion connotes, or that weirdness connotes a bit of fragmentation. And I think, for the sake of, I think you'll agree, for the sake of the consumer, the enterprise, there has to be some, reconciliation of this stuff. I mean, because, that fragmentation, I don't think really.
So I think this is great for Qualcomm, especially finally having a really competitive product and making them a viable solution, I should say viable, a competitive solution, highly competitive solution for the PC segment.
Yeah.
But I think for the PC segment as a whole, this strategy is really challenging because it's really going to create a lot of confusion.
Well, I mean, it's really weird. A lot of people talked about the Qualcomm X series as sort of the benchmark.
It is.
Right?
Yeah.
It is the processor family to beat. And so, that's an interesting twist.
Yeah.
It is. I mean, and I don't think anyone can really debate that. Even the x86 folks. Yeah. Right.
We've had a chance to play with some of these. Not, we haven't seen the Intel ones. We've seen some of the AMD ones, AMD-based PCs with Strix, and we've seen a lot of many of the
Qualcomm ones.
22 designs that Qualcomm has. So which ones did you like the best?
Okay, I'll start off. I thought the Lenovo Yoga was really cool. And the reason why is I do use a Apple MacBook, 15-inch MacBook Air, and it just had that kind of feel to it. And it was thin. I thought it had a really sleek keyboard. Keyboard was really sort of to my taste and preference. And I thought Microsoft did a pretty good job.
The Surface.
The Surface laptop,
So I agree with you with the Yoga, especially because the Lenovo products also had the integrated speakers, front-facing speakers. It's great, especially if these are creator PCs. I like the NVIDIA-based Snapdragon PC. Very nice looking, very nice keyboard. It didn't, have the speakers.
NVIDIA?
No, sorry. The HP.
There you go.
HP PC. I really like the design. Unfortunately,
it's been a long day.
It has been.
It
didn't have the speakers, which HP is usually very good about their audio.
Yeah.
But I did like the keyboard, and everything else.
Yeah.
Kind of keys, I would say, second place to the Lenovo.
Yoga.
I did like the Samsung products.
Yeah.
Both, and I like the ZenBook on the AMD Strix.
Yeah.
And I really like the 16-inch on the Snapdragon with the OLED display. Gorgeous display.
Yeah. Some of the displays were really nice.
Dell were nice, but I'm not as thrilled about their keyboard. I would say I agree with you. I think the Surface is nice, but it wasn't as sleek as I think the other ones were. So
you're very picky.
I'm very picky.
Yeah, he is. So overall, it was.
Will you give up your Apple for one of these? Now I'm really putting him on the spot.
He's putting me on the spot. I might. We'll see. How's that? I got to get my hands on one first, right? And
we're going to come back to him on that.
I shall. I shall. Yeah. This guy, oh my God. You're bad. You're a bad man. Anyways, hey, look, Computex 2024. By the way, it was my first one.
Really?
It's like, oh, come on. I already told you that. Don't act so surprised.
I know, but I've been coming to these for
I know.
A long time.
I know. But for me, it was an extraordinary experience. I thought it had the weirdest vibe of any conference. It had the feel of disruption, uncomfortableness, a bit of confusion, and
so many
a lot of opportunity. A lot of opportunity.
Yeah.
For players who play their cards right, I think is really what it boils down to.
Well, and this is an inflection point for the market. So, the next 6 months are going to be phenomenal. And I hate to say it, but stay tuned for CES because a lot of this is going to build up through the end of the year. And I think CES, we're going to see even more stuff. So it's going to be interesting. It's going to be a very interesting period. Yeah,
and don't forget 5G PCs.
Absolutely. Oh, that's something that, we kind of got dropped from some of the Snapdragon designs, but there are a handful coming out with 5G modems. And quite honestly, I believe every mobile device should have a 5G modem.
Yes. And Bob O'Donnell will be very happy when that happens as well.
Yeah.
So, but anyways, hey, Jim, thanks so much, man. It's great to have you on. We're going to...
You say that now.
I know. I already regret it, believe it or not. But we will be having a lot more collaborations, and we'll also be bringing on some of our friends who are amazing analysts with deep experience as well as legacy in the industry.
Did you just call me old?
Yes, you are old. I think it's pretty obvious.
Hey, I resemble that remark.
But stay tuned and make sure to check out Tirias Research at
www.Tirias Research. It's TIRIAS Research.com.
And Leonard Lee at Next Curve at www.next-curve.com. Remember to like, subscribe, comment, tell us what you think. And remember, this is just the tip of the iceberg. And so if you would like to get more details and find out more, we are always looking for clients. So
always happy to help.
Hit us up and we'll be happy to talk to you. And Jim, once again, thank you so much. I'm looking forward to our future collaborations and reporting live from Taipei City here in Taiwan, covering Computex 2024. This is Leonard Lee of NextCurve and Jim McGregor of Tirias Research signing off.